Okay, so I'm sharing my screen now. If you can see the screen, say yes. If you cannot see the screen, say no. Should be able to see the PDF. All right, yes, very good. Okay, so today is the second lesson of systems of equations. Last time we learned about substitution. So today we're going to start off with homework questions and then review substitution. And we're going to learn elimination. Right? It's another method to solve systems. And you're going to have to, when you know both of them, you're going to have to like look at the problem and you have to decide which method is the best to use. That's also very important. And then we'll have some practice problem. Okay. Let's begin with our first homework question. You're supposed to solve these with substitution. All right, everybody just post your answers in the chat and we can go over it. All right, we have some answers. Most of you guys said 7-0. All right, very good. Let's look at this. Okay, so 7-0. So let's find some volunteers. Who volunteers to help us solve this? All right. Oh, William. Okay. William, how did you solve this?
So I first solved V by turning and I turned U into 7 minus 5V over 4 by using the first equation and doing 4U equals 28 minus 5V and U equals 7 minus 5V over 4. So after that, I just plugged 7 minus 5V over 4 into every U in the second equation. So I did, which turned the second equation into 2V plus 9 times the difference of 7 minus 5V over 4 equals to 63. And after that, I did 2V plus 2V plus 63 minus 45V over 4 is 63. Then after that is 2V minus 45V over 4 is 0. Then 8V minus 45V is 0. Negative 37V is 0, so V is 0. After that, I plugged 0 into every V in the first equation, which got me 4U plus 0 is 28, so U is 7.
Hold up a second. Could you compute this for me again? What was it?
So
Let me write it your way. 7
Oh,
minus 5v over 4, right? And,
yeah.
okay, plus
Yeah. So
63, and then minus
yeah,
45v over 4
e- e-
equals 63.
63.
This cancels out, right?
Yeah, and then after, which means that 2v minus 45v over 4 is 0. And then I multiplied everything by 4, which got me 8v minus 45v is equals to 0. And then I did 8v minus, and I knew 8v minus 45v is negative 37v, with,
Right.
and negative 37v is 0. So v is 0. Then I plug 0 into every v in the first equation. So 4u plus 0 is 28, and u is 7.
All right, very good. And then you can also write it like this. Good. Okay. So hopefully everybody understood that. I think most of you that turned it in got it correct. So that's pretty good. All right. Second question. Wait, hold on. I accidentally closed out the PDF for some reason. All right. Hold on a second. I don't know how that happened. Should be able to get it out.
Here's this in my property. You want me to kick?
All right, there you go. Okay. All right, so our answers are 10 and negative 11. Very good. Are there any other questions or answers? If not, we can go over this. So how about Kaylee? Can you explain this, how you solved it?
Okay. So I made it so that it was 30p in every equation. So I multiply first I changed the second equation, so it turned into 5p plus 8q equals negative 38. And then I multiplied it by 6, so it was 30p plus 48q equals negative 228. And then I took the top equation and multiplied it by 5, so it was 30p plus 35q equals negative 85. And then, so 30p is equal to negative 85, subtract 35q, sorry. And so if I substitute that in for the second one, then it's equal to negative 85 subtract 35q plus 45q is equal to negative 228. And so that equals 13q equals negative 143. And so q is equal to negative 11. So I put it in the first equation, so that the first equation now turns into 6p plus 7 multiplied by negative 11 equals negative 17. So 6p minus 77 is equal to negative 17. 6p equals 60, and then p equals 10.
All right, very good. And then you can write it like this. Great. And this is actually the elimination method that we're going to learn today. You can also solve it with substitution, but I feel like your elimination method was a bit more efficient here. So that's good. Third one. Oh wait, I'm not sharing my, oh shoot. Sorry about that. Here it is. This is for the last problem. You can copy it down if you want. So basically, what she did was she multiplied the first one by 5 and multiplied the second one by 6, and then see both of them have 30p, so they can cancel out the 30p using elimination. I'll talk more about elimination later. Actually, let me show you how to do substitution with this one, because that was what we were learning last class. So let's use substitution. So basically, if you use substitution, let's say we can find the value of p. So 6p is going to be equal to negative 7q minus 17. P is going to be equal to negative 7q minus 17 over 6. All right. And then just substitute that in for all the p's. All right. And then this is not an 89, that is 8q. All right, and then we get negative 35q minus what is this? 85 over 6 plus 8q is going to be equal to negative 38. All right, I think that's correct. All right, then multiply everything by 6, right? So then we have negative 35q minus 85 plus 48q is going to be equal to negative, what is this? 228, I think. Was that it? Yeah, I think so. All right, and then move the negative 85 to the other side. Then you get 13q on this side. Get what, 143. And then you still get q is equal to 11. Do the same thing. You can substitute in q as 11. Oh no, negative 11, and then get the same result, right? All right, very good. Let's do the third one now. All right, we have 1, 3 as our answers. Okay, so let's see who wants to volunteer. All right, William. All right, William, show us how to do it.
So first, I decided to find y in terms of x. So I turned the first equation, 5x plus y minus a equals 0, to 5x plus y equals 8. Then I turned it to y equals to 8 minus 5x. So after that, I plug 8 minus 5x into every y in the second equation. So I got -3 times the difference of 8 minus 5x plus 7x plus 2 is equal to 0. Then I got -24 plus 15x plus 7x equals to -2. And then it is 22x equals to 22. So x is equal to 1. After that, I plugged 1 into every x in the first equation. So I got 5 plus y minus 8 equals to 0. And after that, I got 5 plus y equals to 8. So y equals to 3. So x is equal to 1 and y is equal to 3.
All right, very good, very good. Okay, so hopefully nobody has any questions about that. I think we are good on that. You seem to have very good understanding of it. Okay, let's review some things we learned last time, and then we can dive into new material. So let's review what a system is. Definition of system is set of simultaneous equations with common solutions that fulfill all the equations, right? So if you have something like this, we're gonna have to find as a solution x, y that is true for both equations, right? So that's pretty self-explanatory. Let's move on to the graph of a system. All right, so we're reviewing graph of a system. It's what systems look like if you graph them, right? The solution of a system is basically just an intersection, right? So the system shown here is x plus 2y is equal to 6. And then y is going to be equal to x, right? So what we do is we're going to find the intersection of these two lines that are graphed, and that's going to be the solution. The solution here is 2, 2. And since, intersection is a point, we also tend to write the answers of systems in like a coordinate point format, right? Like x, y, right? So let's say x is equal to 1, y is equal to 4, then your solution would be 1, 4, right? So let's review solving with a little bit of substitution, right? So we already know what y equals, right? It equals x. So what we can do is we can substitute y in for all the x's, right? So y plus actually, we could do that, but could also do x plus 2x, not 2y. 2x is equal to 6. Or you could also do y plus 2y. Doesn't really matter because y is equal to x. So once you find one, you know the other one. So this one, obviously, x is equal to 2, and since it's also equal to y, right? Y also equals to 2, so you get 2, 2. It's pretty self-explanatory. And however, substitution does tend to get a bit long sometimes. Right, with the homework problems, some of them were pretty long. If you try to do the substitution, quite tedious. You can make a lot of mistakes. So you have to decide for yourself uh, what's the best method to use here, right? What's the best method? Should we use elimination or substitution? Or right now we only know substitution, right? So it's the only thing we can use. But sometimes elimination is more efficient. That's why I'm teaching you both. Okay, so we're going to use that same example and let's switch things around a little bit. All right, so let's call this equation 1 and equation 2. All right, so it's just switch things up a little bit so it lines up, right? All the variables on one side, numbers on the other. It's easier to look at this way. All right, so let's look at the first equation. All right, let's look at the first equation. So let's like this, right? So what if we added the first equation to the second? No, the second equation to the first equation. So if we add the second equation to the first equation, we're going to do this. We're going to add negative x plus y. It's going to be equal to 6 plus 0. All right, and you can see that the x's cancel out. So you're going to have 3y is going to be equal to 6. Y is going to be equal to 2. Right, and that's how you cancel out the x. Look, if you add both of these equations together, the x's, when they add together, it cancels out. The y's turn into 3y, and this is just still 6. Right, and then you get just 3y is going to be equal to 6. Right, so y is equal to 2. And then you know that y equals to x, right? So x also equals to 2. However, it might not be that easy always, right? So what if you have like another example? Let's do something similar. We have 2x plus y is going to be equal to 6, and then 3x minus minus 3y is going to be equal to 5. All right, let's see. We're going to do that. Okay, so what will we do here with elimination? So one thing we could do is, going back to what Kaylee did in homework problem number 2, we can multiply the first equation by 3 to get 6x plus 3y, and then is equal to whatever. And then for the second equation, we can multiply by 2, so we get another 6x. So then we can subtract the two equations and cancel out the x. Another thing we can do is we can just multiply the first equation by 3. All right, so let's multiply the first equation by 3 because that's a little bit easier. So you multiply everything by 3 here. All right, we don't need to cancel out the x. Instead, we can just cancel out the y's. Once we multiply everything by 3, you'll see, right, there's a 3y and negative 3y. So you just add them, right? You get 9x is going to be equal to 23. x is equal to 23 over 9. And then, of course, you can then solve for y. Right, dot, dot, dot. Okay, so if you can't just, if you don't have like x and negative x and you just directly cancel it out, you're gonna have to make it so that you can cancel it out. And you can multiply numbers to these equations to make it so that it will cancel out, right? Because not every equation is gonna have like y and negative y for you to cancel out. It's not gonna be that straightforward, right? So are there any questions? Are there any questions about the elimination method? Any questions? All right, no questions? If there are no questions, let's move on to some practice problems. I have 3 practice problems for you guys. And since elimination is a little bit harder to grasp than substitution, I'll give you a bit more time for each of these questions, approximately like about 5 minutes for you guys to really think this through, right? So make sure you check your work, right? And just think about your answers, right? So think about how you can cancel these variables out, right? And if you really don't get it, you can just wait until I go over it. All right. So let's begin with this first problem. All right. Remember, if you can cancel, let's say this is equation 1, equation 2, right? Remember, you can add or subtract these equations to cancel out variables, right? Just a hint for our first one, there's a q and a negative q right here. So you can definitely cancel that out once you get the format right. So make sure you do that. Right, let's go over this. So we have 1, 1. That's our answers. Okay, so let's go over. Let's see. Zebo, can you tell us how you did this problem? Or are you not done yet? All right, if you're not ready, that's fine. Who else wants to? Oh, okay, William. All right, William. How did you?
So I first just change the order, just change the second equation to 7 minus q equals to 6p. And after that, I combined the equations and got p plus q plus 7 minus q equals to 2. And equals to 2 minus 6p plus 6p. And after that, the q's cancel out, and I moved the 7 to the other side and the 6p to the other side too. So it is 5p equals to negative 5, which means p is equal to 1. After that, I plugged up, so p equals to 1. And after that, I plugged 1 into every p in the second equation. So, I mean, in the first equation. So 1 plus q equals to 2, which means q is equal to 1.
Very nice. All right. Let's move on. All right, let's go over this one. So what you need to do here, let's rearrange this a little bit so we lined up. So negative 3u plus 4t is equal to 0, and then 9u plus 5t is equal to 9. All right, so let's multiply the first one by 3. You get negative 9u plus 12t is equal to 0, 9u plus 5t is equal to 9. And if you add these equations, you're going to get 17t is going to be equal to 9. Because the u's cancel out. And then t is going to be equal to 9 over 17. Right? And then you can plug that back in. 4 times 9 over 17 minus 3u is going to be equal to 0. So 36 over 17. So let's just multiply everything by 17 first. So you multiply everything by 17, you're going to get 36, right? Minus 51u is equal to 0. And then you get u is going to be equal to 36 over 51. Very ugly numbers. I hate these numbers, but that's the answer. All right, let's see. Grace, how did you get t is equal to 1 and u is equal to 0? If you plug them in, the numbers don't match up, right? So make sure to check your work, right? All right, the third question. All right, let's go over this one. So this one got some pretty ugly numbers too. So let's see. Let's rearrange this. All right. Then how about let's to multiply the second one by -2. All right, and then we can add. So then we get -17y is going to be equal to -112. Y is going to be equal to 112 over 17. William, you got a different answer. Let's see if that's correct. We're going to have to plug that in. But anyways, let's find the x. All right, so 6x, right, plus 32 is going to be equal to 7 times 11, 1012, and then some. All right. Okay, and then, okay, these are really, really ugly numbers. All right, we have 6x is going to be equal to this piece of junk minus 32. Get out your calculators. Let's multiply everything by 17. 17 times 32 is going to be 544. 7 times 1, 2, all right. All right, well, that's really ugly. Divided by 6. What? That makes x equal to 40. That's weird. All right. I don't know if that's correct because I didn't pay that much attention to the calculations. William, could you explain your answer because we have differing answers?
Wait, can you go back to the PDF, please? Wait, so I just combined the equations right after, like first I multiplied the second equation by negative. Oh wait, I did something wrong. Oopsie.
Okay. Okay, so that's the problem. All right, let's see what the others got. 6, 10 out of 15. All right. I think that's correct. And then, all right. Yeah, so this one had some ugly numbers. The homework probably won't have that much ugly numbers. So just make sure to check your work when you're doing this. Because elimination could be very a lot of ugly numbers, you know? All right, so that's the last problem for today. Thank you for listening, and I'll see you next week.
Bye.
Bye.